Domain and range practice problems. So this will hopefully continue to solidify your knowledge around domain and range. And now we are going to be reading a graph. So let's take a look at this problem. It's about a bouncing ball. So let's go ahead, take a look at it. It's telling us that we have a ball that was dropped from a certain height. And obviously here, if I'm looking at it, I'm just gonna just make note. So it looks like it was dropped right here. And then this is when it hit the ground. It bounced, right? So a tennis ball was dropped from a certain height. It bounced several times and rolled along for a short period and then stopped. So that's what this is about. We are told that the function name is h and gives its height over time. So again, there's that function notation, that function verbiage. Function over time. What am I talking about? I'm talking about the height of a tennis ball over time as it bounces. All right. So you can see here that we've been given a partial graph. Partial means not complete. So, and I also want you to note what? That height is being measured in feet and time is being measured in seconds. So right then and there, what I'm going to do, stop the video. I'm going to actually put that information into the graph. All right, so you can see what I did here was I labeled height in feet along the Y and time along the bottom, which is my x-axis. All right, we are going to use the graph to help us answer some questions. And note here, it says, be prepared to explain what each value or set of values means in this situation. Again, we go to this whole thing about understanding what the situation is telling us, what it means. So what do I know? Let's just talk about what do I absolutely know. Well, I know that we are talking about a tennis ball that was dropped from a certain height. So here it is right here. I'm going to pretend that I've dropped this ball and the ball follows along this path, bounces right here, follows along the path, comes back down, bounces again, back down, bounces, keeps going, bounces. And notice that it bounces, but according to this, it says it bounced several times, rolled along. Well, I don't see the rolling along, right? I just see where it is hit the ground. So this is the ground. And basically, we're able to time it like every place it hits the ground and how much time that evolved. All right, so I'm going to clean up my graph here. I'll be right back. Okay, you can see I just cleaned up. I got rid of all my bouncing balls, but I did leave the notation that says that the x-axis is the ground. All right, so let's see, what do we have to answer first? We need to find h of 0. So one of the things I want you to remember, h is the name of the function. 0 is the input. What is the input measuring? Time. So, what is h? H is the height. So, we are asking ourselves, what is h when time is 0? So, when time is equal to 0, so take a look. Where is time 0? Right here. So I'm going to follow this up, and where does my graph? Right here. Note right there. I've got 0. This is when time is 0. This means 6. 6 what? 6 feet. So, in other words, this is telling me what? That the ball at time 0, or in other words, the ball was dropped from a height of 6 feet. I'm going to write that in. All right, so you can see what I wrote here. h of 0. H is the height. Input is time. Time is 0. I went in and I noted up here that when time is 0, the height of the ball is 6 feet. In other words, another way I could say that is the ball was dropped from 6 feet. And if you go back up here, it says a tennis ball was dropped from a certain height, right? Well, what was that height that it was dropped from? 6 feet. So right here, this tells us it was dropped from 6 feet. And I read it off the graph. All right, let us continue. So now it's asking us for h of x is equal to 0. All right, so this is where I have to kind of think about what does each part mean. So we know that h is the name. The name is, we're talking about the height of the tennis ball. I do not know what x is. Remember, x is the input. So I don't know what that is. That's a question mark. That's why they've got h of x, because I've got to figure out what that x means. What is the input? When what? When the height is 0. So this is the height, which is also the output. Remember, the h is the output, the time is the input. Let's just write that down. We've got input for time, and the height in feet is the output. All right, so when is the height 0? When is the height 0? So let's take a look. Here is 0 right here. Here's when the height is 0 right there. So take a look. Look at all the time. Look at all of the heights. Well, when is the time, or when is the height, sorry, when is the height 0? Right here, right here, right here, right here, right? So what is the time? What is the time? 0.54 or 54 seconds, because remember we're reading it in seconds. When else? Right here. 1.48. Right here. 2.25. So 148 seconds, 225 seconds, or 0.54 seconds, 1.48, 2.25. So right there are three values. So all I did was I thought, okay, what is x? That is what we needed to figure out. What was the input when my height was 0? So again, reading the graph. All right, let's continue. Okay, so now we're going to layer on, and it says to describe the domain. So remember, domain are all of the inputs. So think about it. Domain are all the inputs. So I've been given all of the inputs. It's all of the time that the ball hit the ground. So it is all of the values. I'm describing it, right? I'm putting into words all of the values when the ball hit the ground. And what are all the values? That means it's the time in seconds. All right, so let's just list them, right? Because we can. We can list them right now. we've got 0.54 seconds, comma, we have 1.48 seconds, we have 2.25 seconds, right? So those are all the inputs. I could even, in a sense, put 0 seconds, right? Because at 0 seconds, that's when I dropped the ball. All right, now that's describing the domain. Remember, domain are the inputs. The inputs are the time. So now, let's talk about the range. Remember, the range are the outputs. So what are all the possible outputs that happen as a result of me dropping the ball? So think about it. What if the inputs measures the time, then the outputs measure the height. So the range are all of the values or the height. It's all the values of the height of the ball. So I'm going to write that in right now. So take a look what I wrote. I wrote the range are all the values of the height of the ball when it bounced. And according to the graph, I can figure that out. So let's take a look. So right there, right there, right there, right there. So, but I'm not going to do that right now just because it would be really difficult for me to read the graph. But that's what all the range is, or all of the values that came out in terms of the height. So I'd have to then look at each one of those and figure it out. All right, so hopefully that's a good way to kind of use the graph to answer our questions. In fact, I really love when I get to answer questions using a graph because the graph is very much a picture of what is going on. All right, here's another one. We've got, this is problem number, it's actually on the second page. So we've got a child tosses a baseball up into the air. Okay, it could be a tennis ball, it could be a soccer ball, it could be anything, right? But a child tosses a baseball up into the air. On its way down, it gets caught in a tree for several seconds before falling back down to the ground. Okay, that makes sense. I throw the ball up into the air, it gets caught in the tree, and then it stays there for a few seconds, and then it falls back down to the ground. Oh, and I even see the graph. In fact, the graph kind of gives me a picture of what happened. All right, so now take a look. I am going to just quickly talk about this graph. We've got that a child tosses the ball up into the air. So starting right here, this is where this child tosses the ball up into the air. It gets to a maximum right there, falls down, up, gets caught in a tree. Here it is right there, caught in tree. And then it falls back down, falls back down. And that's when it hit the ground. Hit the ground. All right, and here's where it started from. Started. All right, so we're going to select the best description of the range. Oh, there it is. There's that word, range. Remember, range are the outputs. So when I'm thinking about outputs, I am thinking about the what? I am thinking about this line on the graph. In fact, I'll draw it right here. This is where I'm talking about. I'm going to be looking over there. All right. So I just want to go ahead and I'm going to stop the video. I'm going to clean this up a little bit so that way we can actually get to the questions to answer. All right. So you can see I've cleaned this all up. And like I said, we're going to be looking along this line right here because we're talking about the range. All right. The range includes all numbers from 5 to 12.5. Okay, the range includes all integers. Integers are positive and negative whole numbers. So -1, -2, 1, 2, 3, 4. No fractions or decimals, okay? Between 0 and 12.5. The range includes all numbers from 0 to 8.5, and the range includes all numbers from 0 to 12.5. All right, so remember what I said is we're looking at the graph. We are reading the graph on where does the graph start and where does it like reach its full-on point. All right, so take a look. Starts here. Okay, so, and what's, oh, that's where it starts, but then it goes up to here with my blue dotted line, and look at the end it falls back down to the ground. So right here, I also have to look at the end of the graph as well. So if I look at the span of numbers between here and here, let's think about it. We're talking about the height. So range includes all numbers from 5 to 12.5. So that would be from here to here. Nope, it's not that one because I got to go all the way to the ground. The range includes all integers. So between 0 and 12.5. Well, right then, see that 12.5? That automatically tells you that I've got to include fractions. So it is not that one because it just says positive and negative numbers. Well, no, we got to account for fractions too. The range includes all numbers from 0 to 8.5. Well, 8.5 is about right here. Well, no, it's not that one. So it's the range includes all numbers from 0 all the way up to right here, which is 12.5. So this is the correct one. That is the best description of my range. It includes all those numbers that fall within that graph. All right, question number 2. To raise funds for a trip, members of a high school math club are holding a game night in the gym. They sell tickets for $5 a person. The gym holds a maximum of 250 people. The amount of money raised is a function of the number of tickets sold. So think about it. That means is the amount of money raised depends on how many tickets they sold. So I'm going to write that down. So the amount of money raised depends on how many tickets are sold. All right. So which statement accurately describes the domain? So I want you to remember, domain are the inputs. So let's write that down. Domain are the inputs. So take a look here. This time I'm not talking about time. The input is the number of people that could attend this function. Okay, so the number of people who can attend this game night is the input. All right, so think about it. All numbers less than 250. Wait a minute, where did 250 come from? Oh, 250 are the maximum amount of people that can attend this event, right? Because the gym only holds 250 people. So all numbers. Ooh, when we talk about all numbers, we're talking about like fractions, negatives, below 0. Okay, I don't know about that. All integers. Well, remember, integers are positive and negative numbers. All positive integers. Ooh, I like that, right? Because when we're talking about people, we're not talking about negative people. And the other one says all positive integers less than or equal to 250. Well, less than or equal to. Yep, I'm going to go with that one. Because this one, it just says all positive integers. So all positive integers are every number that's positive. It didn't put a stipulation around that 250. Remember, we can only get 250 people into the gym. So I can't have 500 people because it won't work. So this last one, why is it this last one? Because first of all, it's all positive integers. So because I have to have positive numbers when I'm talking about people. Less than or equal to 250. I can have less than 250 or I can have 250, right? But I can't have more. All right, so this is why it is D. It is D. And hopefully I've explained it in good enough detail for you as to why I selected that one. All right, next one. The graph H shows the height in meters of a rocket T seconds after it was launched. All right, so take a look. H, height in meters. So right here, the very first thing I like to do is I always like to put all the information. So this is the height in meters. What else do I know? Oh, that the bottom is time. Ooh, love when it's time. And how am I measuring time? I'm measuring it in seconds. All right, so now we've got this rocket that's launched from a certain height, and it starts here, goes up, reaches the height, and comes back down. This is when it hits the ground. All right, so let's go ahead, and it says find H of 0. So think about it. H is the height. So right here, there's my height. The 0 is the input, and the input is time in seconds. So I want to know, what is H when the time is 0? What is H when the time is 0? So take a look. Here's where time is 0. I'm going to go up till I get right there. So this is the height when time is 0. Looks like it's about 15, don't forget the units, meters. So what does this value represent? It is the starting point of the rocket. It is the height from which the rocket was launched. All right, so it is the height from where the rocket was launched. Okay, and I read the graph to get that information. So now it says describe the domain. So in words, what can you say about the inputs? So we know that the inputs are all time. We know that. All right, and the time from what? Read the graph. I'm going to circle it in blue. The time from here all the way to here until it hits the ground. So time from 0 up until what? 4.8 seconds? Definitely. So the time started at 0. That's when we launched it. And over time, right, along the bottom until it hit the ground. So the time from 0 to 4.8 seconds until it, or the rocket, hit the ground. So that's describing, that's describing the domain, or all of the possible inputs. Remember, the domain are inputs. All right. Now it says to describe the range. So remember, what is range? Range are all the outputs. Okay, so when I talk about the outputs, I'm looking at the height. So what we're going to do is we know that right here is where it hits the ground. So from here and to the maximum part right there of how high did my rocket get. So this is describing the range. So it is the height of the rocket from 0 until it reaches its maximum height at about 35 meters. So that is my range. Okay, you can see what I wrote. The range is the height of the rocket from 0 when it hit the ground to 25 meters, meaning that was the maximum height. So one of the things I want you to remember when I read a graph, I'm looking at the whole graph. I'm looking at the whole graph. So you might say, oh, well, the range starts here, Mrs. Hennefarth, because that's when it started. It's like, yeah, that's when it launched. But if I look at the overall from here to here. So I've got to look at the entire graph. So just remember that. All right, now, find h of x is equal to 0. So remember what I said. We know that x is the input. And do I have a number there for the input? No. So this is my question mark. So I need to find x when what? When my h is 0. So when h is 0, that's the height. The height is 0. So what is the time when my height is 0? So let's go back and look at the graph. Okay, so you can see I cleaned up the graph a little bit. So right here is when my height is 0. This is, remember, the ground. So what is my time when the ground or when the height is 0? So right here, right there. So what is the value there? Approximately 4.8 seconds. So remember, we're trying to find what x is. X was the input. So, and remember, I'm measuring my input in seconds. So basically, the rocket hits the ground in 4.8 seconds. All right, so this last piece was the rocket hits the ground in 4.8 seconds. All right, so number 4, I'm going to do, let's see here. I think I've got, is there any more after that? No. So I am going to do number 4 separately, so as a way to kind of not run out of time.